When running OpenAI or Anthropic-based applications on Amazon Bedrock through the Bedrock Mantle endpoint, you previously lacked visibility into inference traffic and usage patterns, making it difficult to monitor performance, troubleshoot issues, or allocate costs. You can now monitor inference traffic to the Bedrock Mantle endpoint using CloudWatch metrics published under the AWS/Bedrock Mantle namespace. You can track token counts and error rates by project, enabling you to understand usage patterns at account, project, model, and model granularity levels. You can set up alarms for production workloads to detect anomalies or capacity issues in real time. You can attribute usage and cost to teams by leveraging metrics broken down by project and model, allowing for chargeback and resource planning. Access these metrics through the CloudWatch console by selecting the AWS/Bedrock Mantle namespace in supported regions. Debugging GPU hardware faults, diagnosing NCCL communication failures, and identifying performance bottlenecks across distributed clusters requires manually accessing nodes via Systems Manager, parsing logs across instances, and cross-referencing documentation. SageMaker HyperPod troubleshooting skills address this by enabling you to diagnose cluster issues through natural language in AI coding assistants like Claude Code and Cursor. You can validate cluster health and detect hardware communication failures using encoded AWS best practices that guide AI agents to collect evidence systematically. The skills analyze software version drifts and generate diagnostic reports with actionable recommendations. You can install the open-source skills plugin from the OS Labs repository for both Slurm and Amazon EKS orchestrated clusters without modifying your existing HyperPod infrastructure. When running distributed training workloads on SageMaker HyperPod, you need internode communication bandwidth for performance. Previously, configuring EFA interfaces attached both an EFA device and an ENA device to each interface, consuming IP addresses even when IP networking was only needed on some interfaces. This led to IP address exhaustion in your subnet, limiting the number of nodes you could deploy. With EFA-only network interfaces, you can configure EFA devices without ENA for IP networking, preventing IP address exhaustion in your VPC subnets. You can scale clusters with more dedicated EFA interfaces for low latency, high throughput communication. To enable this, you specify EFA only in the cluster network interface configuration when creating or updating your HyperPod cluster via the Create Cluster or Update Cluster API. This configuration lets you deploy larger clusters within the same subnets without encountering IP exhaustion, which is beneficial for training jobs where internode communication bandwidth is critical. When you run multiple virtual interfaces on a single AWS Direct Connect dedicated connection, unexpected traffic spikes on one VIF can consume all available bandwidth and impact workloads on other VIFs, causing network congestion. VIF rate limiters address this by letting you set maximum bandwidth allocations for up to 10 VIFs per dedicated connection, with capacity options ranging from 50 megabits per second to 1.6 terabits per second when using link aggregation groups. Rate limiting applies to both ingress and egress traffic, and excess packets are dropped when a VIF exceeds its configured capacity, preventing it from affecting other VIFs. You can monitor traffic utilization as a percentage of configured capacity and track drop packets through CloudWatch metrics, allowing you to set alarms based on your thresholds and adjust bandwidth allocations as needed. You can configure rate limiters through the Direct Connect console, API, or SDK across all regions where dedicated connections are supported. Previously, all tenants in an SES account shared a single suppression list, which meant that email issues from one tenant would suppress emails for all other tenants in the account. This created problems for SaaS providers sending on behalf of multiple customers, enterprises separating transactional and marketing mail, agencies managing different brands, or any application managing distinct email streams. With tenant-level suppression lists, you can now isolate bounces and complaints per tenant so that issues affect only the tenant that generated them. You configure suppression behavior using two settings: suppression scope set to either tenant or account, and suppressed reasons set to bounce, complaint, or both. SES automatically records bounces and complaints to the appropriate tenants list. You can also manually manage suppressed addresses using API operations including put suppressed destination, get suppressed destination, delete suppressed destination, and list suppressed destinations with the tenant name parameter to specify which tenant suppression list to modify. Organizations need to deploy advanced language models in production environments while maintaining enterprise security, governance, and operational consistency across their infrastructure. You can now use GPT 5.5 and GPT 5.4 in production workloads on Amazon Bedrock with the same security and governance controls you use across AWS. GPT 5.5 runs on the Bedrock next-generation inference engine for agentic coding, data analysis, and multi-step tasks. You can use Codex for AI-powered software development through the Codex app, CLI, and IDE integrations with Visual Studio Code, JetBrains, and Xcode. You can configure Codex to run inference through Bedrock with pricing that matches OpenAI rates and usage that counts toward your existing AWS commitments. In regulated healthcare and life sciences environments, you need to validate bioinformatics pipelines before adopting new engine versions, but testing across versions typically requires modifying workflow source code. AWS HealthOmics now addresses this challenge by allowing you to specify the Nextflow engine version at runtime through the StartRun API. You can specify Nextflow versions 22.04, 23.10, 24.10, 25.10, or 26.04 using the engine settings parameter. This runtime parameter overrides any version specified in the workflow manifest, enabling you to test the same workflow across multiple engine versions without code changes. You can maintain production workflows on validated versions while development teams test newer versions in parallel, reducing risk of unexpected behavior. This capability supports controlled migration paths required in regulated environments where pipeline validation is mandatory before engine upgrades.